I welcome you all to another lecture on HVDC power transmission systems. In our last lecture, we completed our discussions on two-value conduction of AC to DC converter, phase controlled converter. We assumed U equal to 0, that is no overlap angle, and because of no overlap angle, there was two-value conduction. It was assumed that the transformer leakage inductance and the system inductance is 0. So wherever a valve is fired, it immediately goes into conduction and there is instant transfer of current from outgoing valve to incoming valve. Today we will take the practical case. Practically, you cannot ignore the transformer leakage inductance and the system inductance. The inductance is there always. And this inductance will always, delay the transfer of current from outgoing valve to incoming valve. And for some time, which is represented in terms of overlap angle, or we can say overlap time, both the values will be on. That is, outgoing value as well as incoming value will be on. And after the overlap angle or overlap time is over, current will be completely transferred to the incoming value. So today we will study converter analysis with commutation overlap. So that means converter transformer leakage reactance or source inductance is not zero. It is not zero. It is the converter transformer inductance and the system inductance is considered. So that means U is not equal to 0. So as far as this U overlap angle is concerned, what will be the range of this overlap angle? Based on the magnitude of overlap angle, we can have three different modes of operation. Mode 1 is U less than 60 degrees. U is greater than 0 degree but less than 60 degrees. And this mode gives 2 and 3 value conduction. 2 and 3 value conduction. I will come to it in a minute's time. This is mode 1. Second mode is mode 2. And in mode 2, U is exactly equal to 60 degrees. And this gives 3 value conduction only. There is no 2 value conduction. There is only 3 value conduction. And mode 3 is U greater than 60 degrees but less than 120 degrees. So this will give 3 and 4 value conduction. 3 and 4 value conduction. But that means when the converter operates at a given instant of time, either 3 valves are conducting simultaneously or 4 valves are conducting simultaneously. So this occurs only, this situation exists only when U is greater than 60 degrees. And U equal to 120 degrees, which is not a mode, it will give only 4 value conduction. 4 value conduction means short circuit, which means short circuit. And it is an abnormal operation. Abnormal operation. Generally, this U equal to 120 degree hardly exists. The probability of U becoming equal to 120 degrees is very, 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 very low. So even when U becomes equal to 120 degrees, it will give only 4 value conduction, which is equivalent to short circuiting condition of converter, and it is an abnormal condition or abnormal operation. Now, let us consider first mode 1, that is 3 value conduction. So before 3 value conduction, let us take again U equal to 0 degree, which gives 2 value conduction. Before discussing 2 and 3 value conduction, we will go back to what we have discussed in the last couple of lectures. There is no, the source inductance is ignored. It's assumed to be 0. So U equal to 0 degrees. No commutation overlap or no overlap angle is there. So it gives 2 value conduction. And you know this, let me draw the power circuit diagram of converter first. This is value 1, value 3, value 5, 2, 4, and 6. This is DC side inductance LD, and this is DC side current ID, and this is our load. The load voltage is plus minus VD. This is plus positive bus, this is negative bus VD. And this is our phase or line to neutral voltage EA. This is source inductance LS, and this is line current IA. Similarly, this is phase voltage EB, and this is line current IB. This is LS, and this is phase voltage EC. Again, this is source inductance LS. Same inductance in all the three phases. This is line current IC. So this is the power circuit diagram of our three-phase 6-pulse converter. Now for U equal to 0 degree, we get two-value conduction. Two-value conduction can be shown by means of this diagram. Let us suppose value 1 is conducting for some time, then value 3 for 60 degrees, then for 120 degrees, then value 5, then again value 1. Okay. On the bottom side, we have value 6 conducting, then value 2, 4, 6, then again 2. Okay. This total interval is 120 degrees, and this interval, that means here to here, it is 60 degrees, here to here, this is also 60 degrees. So see, this is 60 degree interval, this is also 60 degree interval, and total interval is 120 degrees, because you already know that each pair conducts for 60 degrees, but each value conducts for 120 degrees. So you can see value 1 conducts for 120 degrees, first with 6, then with 2. 6, 1, 1, 2. Similarly, value 2 conducts for 120 degrees. 60 plus, first it conducts with 2, 1, 2, and then 2, 3. Okay. So each pair conducts for 60 degrees, you can see, but each value conducts for 120 degrees. So let us take these instants. This is first 60 degree interval. This is next 60 degree interval. This is next 60 degree interval. Likewise, these are all 60 degree intervals. Let me first of all show these 60 degree intervals like this. So during this 60 degree intervals, you can say in the upper commutation group, value 1 is conducting. You can see value 1 is, and in the lower commutation group, value 6 is conducting. 1 and 6. 1 from upper group and 6 from lower group. So 6 and 1. I can write here 6 and 1 is conducting during this 60 degree period. Then during next 60 degree period, 1 continues to conduct. And in the lower group, firing pulse is issued to 2, and there is instant commutation of current from value 6 to value 2. So 6 is out, 2 is in. So 1, 2. Since U we have assumed to be equal to 0, so when firing pulse here is issued to value 2, it immediately goes into conduction, and there is instant transfer of current from outgoing value 6 to incoming value 2. So 6 goes out, 2 comes in, so 2, 1. So 6, 1, 1, 2. And at this instant of time, firing pulse is issued to value 3. You can see value 3. And as soon as firing pulse is issued to value 3, which is the upper value, there is instant commutation of current from value 1 to value 3, because U is equal to 0. There is no commutation overlap. So 1 completely is out, 3 is in. So 2, 3. 2 continues to conduct, and this is 3. Then similarly, you can continue 3, 4. Then during next 60 degrees, 4, 5. During next 60 degrees, 5, 6. During next 60 degrees, 6, 1 again. So you can see during first 60 degree interval, 6 and 1. This is the pair of valves which is conducting. During next 60 degree interval, 1 continues and 2 comes. So 1, 2. During next 60 degree interval, 3 comes. 3 and 2. So 2, 3. During next 60 degree interval, 3, 4. Then 4, 5. This is 4, 5, because 4 continues to come. 4, 5. Then 5, 6. 6, 1 repeats. So this gives two value conduction. So we have started with 6, 1. 6, 1 will be followed by 1, 2. 1, 2 will be followed by 2, 3. 3, 4. 4, 5. 5, 6. And back to 6, 1. So this gives two value conduction. This is what we have already discussed over last couple of lectures, and we have already drawn waveforms for this situation. Let us now quickly go to mode 1, that is converter analysis with commutation overlap. Now we will not ignore source inductance. We will assume that source inductance is there, and with source inductance there will be commutation overlap. So we will today discuss mode 1, that is U greater than 0 degrees but less than 60 degrees. So 0 less than U less than 60. This is the range of U. It is greater than 0 degrees but less than 60 degrees. So this will give 2 and 3 value conduction. 2 and 3 value conduction. So it will be like this. This is value 1 conducting for 120 degrees, value 3 conducting for next 120 degrees, value 5, and then again value 1. We'll close it here. And here previously value 6 was conducting, okay. Then let me first complete this. Value 2, value 4, value 6 again, then value 2 again. Now this shows commutation overlap. Let me show you the commutation overlap. I will explain it in a minute's time. Please bear with me. Now what is this? Total interval is 120 degrees. Similarly, in this 120 degrees, this is 60 degree interval, and this is another 60 degree interval. So total is 60 plus 60, 120 degrees. Now what is this? This shows commutation overlap angle U on bottom side as well as on top side. This is U degrees, commutation overlap. Now let us see what happens. Let me first of all draw all these projections. We'll stop here. So previously 6 from the lower group and 1 from the upper group are conducting. So 6 and 1. And here firing pulse is issued to value 2. I am showing firing pulse issued to, this is value 2. As soon as firing pulse is issued to value 2, there is transfer of current from value 6 to value 2. Unlike the previous case, there is not instant transfer of current. The current transfers from value 6, which is outgoing value, to value 2, which is incoming value, and it takes some time. And what is that angle or that time? That's called overlap angle, U degree. And in this case, we have assumed that U less than 60 degree. And during this U, that's overlap angle, there is transfer of current from outgoing value to incoming value. So that means during this period, both the values, 1 from upper group and 6 and 2 from lower group, both the values are on. So therefore, during this period, you can see during this small period, here 2 is fired. When 2 is fired, 1 is already conducting, 6 is also conducting. So during this period, 2 is also conducting. So there is 3 value conduction, 6, 1, 2. So this is commutation overlap angle U. During this period, there is commutation taking place between 2 and 6. So during this period, both are conducting, 6 as well as 2. Current in 6 is decreasing and current in 2 is increasing. And at the end of this commutation overlap angle U, 6 is completely out and 2 is completely in. So 1, 2. So there will be again 2 value conduction, 1, 2. Then here, a firing pulse is issued to value 3. You can see value 3 is fired. And there is not transfer of current from value 1 to value 3 instantly. The current transfers from value 1 to value 3 during this overlap angle. You can see this is overlap angle U. So that means during this U degree, both values, outgoing value 1 as well as incoming value 3 are conducting, and 2 from the bottom value is already conducting. So this again gives 3 value conduction. That is 1, 2, 3. Then at the end of commutation overlap angle, 1 is completely out, 3 is completely in. So 3, 2, 2 value conduction. 2, 3. Then similarly, commutation during this overlap angle. There is commutation between 2 and 4. So 2 as well as 4 conduct. So 2, 3, 4. Then 3, 4. Then similarly 3, 4, 5. Then 4, 5. Then 4, 5, 6. 5, 6. 5, 6, 1, 6, 1. This is how it occurs. So therefore, if you start with 6, 1, which is 2 value conduction, and value 2 is fired. So there is commutation taking place between 6 and 2, and during this u degree, 6 and 2 both are conducting, and 1 is already conducting, so it will give 3 value conduction, 6, 1, 2. And once the commutation overlap period is over, 6 is out, 2 is in, so 1, 2, 2 value conduction. Then 3 is fired. So when 3 is fired, there is commutation taking place between 1 and 3. Both are conducting during overlap angle. So 1, 2, 3. And once the overlap period is over, 1 is out, 3 is in. So 2, 3. Similarly, 2, 3, 4, 3, 4, 3, 4, 5, 4, 5, 4, 5, 6, 5, 6, 5, 6, 1, 6, 1. So we can see 2 value conduction 6, 1 followed by 3 value conduction 6, 1, 2 followed by again 2 value conduction 1, 2 followed by 3 value conduction 1, 2, 3. So 6, 1, 6, 1, 2, 1, 2, 1, 2, 3, 2, 3, 2, 3, 4, 3, 4, 3, 4, 5, 4, 5, 4, 5, 6, 5, 6, 5, 6, 1, and then 6, 1. And cycle repeats. So since at any instant of time, either 2 valves or 3 valves are conducting. So therefore, u less than 60 degrees, when there is commutation overlap and the overlap angle is less than 60 degrees, it results in 2 value conduction and 3 value conduction. Now the question is how long, for how much period 2 valves are conducting and for how much period 3 valves are conducting. So I will write here 3 value conduction is there. 3 value conduction occurs for how much time? You can see 3 value conduction occurs during this period, u degrees. Similarly here, during u degrees, this 6, 1, 2, 3 value conduction occurs. During this u degree, 1, 2, 3, 3 valves. So therefore, whenever 3 valves are conducting and commutation between outgoing and incoming valve is taking place, 3 value conduction occurs, and this 3 value conduction is there for u degrees. So 2 value conduction occurs for how much period? How much time? So 2 value conduction is for, you can see, if the 3, see this is total from here to here, it is 60-degree interval. Okay, each interval is 60-degree interval. Out of this 60-degree interval, 3 valves are conducting for u degrees. This is u, and therefore 2 valves will be conducting for how much period? 60 minus u. So 60 minus u degrees. Because total time period is 60 degrees. Out of 60 degrees, 3 valves are conducting for u degrees. So therefore 2 valves will conduct for 60 minus u degrees. So therefore everywhere you will see that these 3 value conduction takes place for u degrees and 2 value conduction takes place for 60 minus u degrees. Fine. So that is about mode 1. U less than 60 degrees. Let us try to analyze. And after analyzing, we'll try to draw the waveforms for converter DC output voltage and value voltage. We can take any value and plot its value voltage. Now let 1-2 pair be conducting. Let us assume that initially 1-2 pair is conducting, and at alpha, that is after a delay of alpha electrical degrees, firing pulse at alpha, value 3 is fired. Value 3 is fired. We will start with the firing of value 3. You can start with the firing of value 1, or somebody may start with the firing of value 2. It's your choice. I am starting with the firing of value 3. Before value 3, there was 2 value conduction, 1, 2 were conducting, 1-2 pair was conducting, 1 and 2. And I assume that after alpha electrical degrees, firing pulse is issued to value 3. So value 3 is fired. So previously 1-2 pair was conducting, and when 3 is fired, so there will be 3 value conduction, 1, 2, 3. So 1, 2 will be followed by 1, 2, 3. So I repeat, previously the pair of valves 1, 2 was conducting, at an alpha firing pulse is issued to value 3 and commutation between 1 and 3 occurs. So during u degrees, 1, 2, 3 pair is conducting. And once the commutation is over, then 2, 3 pair is again conducting. Previously 1, 2, 3 values are conducting, 3 values. So 2 value conduction followed by 3 value. Let us draw the equivalent circuit for both the situations. Let us assume previously only 2 value conduction was there, 1 and 2 values were conducting. So for 1-2 pair conduction, that means when 1-2 pair of values was conducting, equivalent circuit of converter will look like this. So 1 is conducting and 2 is conducting, 1 from upper group and 2 from lower group. So equivalent circuit will be something like this. This is phase voltage or line to neutral voltage EA, and this is source inductance LS, this is line current IA, and this is your value 1 which is conducting, and value current is, let's call this value current as I1. So therefore EA LS 1, and then it directly gets connected to load. So this is your load inductance in series with load, and this is your load, LOAD, load. And when current flows, so current ID flows through load. It flows, and then 2 is conducting, the return path is provided by 2. So 2 is conducting, I will show here, return path is provided by 2. So value 2 is conducting and value current I2 is flowing, and then when 2 is conducting, it goes back to source EC. So this is source inductance LS, and this is IC, and this is phase voltage EC. What about this value 3 and value 6? They are both off. So therefore, if you show EB, phase voltage EB, this phase is open because in the middle leg or in the central arm, none of the valves is conducting. In the first arm, upper valve is conducting 1, and in the third arm, lower valve 2 is conducting. In the central or middle arm, no valve is conducting, so it is open. So this is positive bus voltage VP, and this is negative bus voltage VN, and this is your total load voltage VD, which is equal to positive bus voltage VP minus negative bus voltage VN. Let us see what happens. So this is the equivalent circuit of your converter during 2 valve conduction, and 1-2 pair is conducting. So therefore we can say IA is equal to IC, IA is equal to ID, it is directly equal to load current. And what about IC? IC is also equal to ID. IC is equal to ID, and IB, phase current or line current IB, is 0. And what about valves? In the valves, valve 1 is conducting, so I1 is conducting, it is conducting current ID, and valve 2 is also conducting, I2, and I2 is conducting current minus ID, you can see. What about other valves? 1 and 2 are conducting. What about 3, 5, 4, and 6? So I3 is equal to I4 is equal to I5 is equal to I6. All other valve currents are 0 because only 2 valves are conducting. One upper valve, valve 1, it conducts the current ID, and lower valve conducts the current minus ID. Okay, all other valves are off. So I3, I4, I5, I6, all these valve currents are equal to 0. So therefore, what is positive bus voltage VP? You see, when valve 1 is conducting, this positive bus gets connected to EA, so it is equal to EA. And what is negative bus voltage? VN. When bottom valve 2 is conducting, you can see 2 is conducting, this negative bus gets connected to EC, so it is equal to EC. So therefore, what is load voltage VD? It is positive bus voltage minus negative bus voltage VP minus VM, that is EA minus EC, that is EAC. And we have seen it in the last class also when we were drawing the waveforms. When 1-2 pair of valves is conducting, the load voltage is equal to the segment of line voltage EAC. So our load voltage is simply equal to EAC. EAC is the line voltage. It is equal to the segment of line voltage. Now once the 1-2 pair is over, after alpha electrical degrees, firing pulse is issued to valve 3, and the commutation between 1 and 3 starts, and this gives rise to 3 valve conduction, 1, 2, 3. Let us draw the equivalent circuit for 3 valve conduction. For 1, 2, 3 conduction, when 3 valves are conducting, earlier 2 valves, 1, 2 were conducting, and now 3 valves, because 3 has been fired, commutation between 1 and 3 is continuing during U electrical degrees. So during this U period, 3 valve conduction is there. So for 1, 2, 3 conduction, let us draw the equivalent circuit. So equivalent circuit is like this. See, 1 is conducting, 3 is also conducting. So 1 and 3, they share the common cathode, you can see. So therefore equivalent circuit will look like this. This is your EA, this is line current IA, this is source inductance LS. So this is your value 1. And how much current it is carrying? It is carrying current I1. And simultaneously 3 is also conducting. You can see 1 and 3 both are conducting. So this is my EB. And line current is IB. The source inductance again is LS. And 3 is also conducting. This is my value 3. And it is conducting current I3. So they have common cathode. You can see 1 and 3 both are conducting and they have common cathode. So common cathode. And then current flows through the load. This is my load inductance. Inductance connected in series with the load. And this is my load. This is the load. And load current is ID. And return path is now, which value in the bottom group is conducting? 2. 2 is conducting. And return path is through 2. So this is 2. So this is LS. This is I2. This is EC and this is IC. And this is the neutral. So this is positive bus voltage VP and this is negative bus voltage VN, and total load voltage VD is equal to VP minus VN. So this is your positive bus, this is your negative bus. Now this is the equivalent circuit. 1 is conducting, 3 is also conducting. So there is commutation taking place between 1 and 3. Current in 1 is decreasing, current in 3 is increasing. Both are conducting. You can see both are conducting during commutation overlap period. And then sum of two currents, I1 plus I3 is equal to ID. And return path is provided by this value 2. It's like this. So this is the equivalent circuit. Okay. So we can now say that I1 plus I3. This I1 plus I3, what is this equal to? It is equal to load current ID. And what is I2? I2 is also equal to load current ID. Return path is provided by value 2. Now what is this? See, negative bus voltage VL is equal to EC, because this load through value 2 and value 2 is connected, directly connects the negative bus to EC. What about positive bus? Positive bus is connected to both phases, phase voltages. It receives both phase voltages, EA as well as EB. So I can apply Kirchhoff's voltage law in this loop. So by KVL, let me apply KVL first to this branch. So EA plus LS di1 by dt is equal to VP. So you can see this voltage plus this drop is equal to this voltage, positive bus voltage. Let me call this equation as equation 1. And similarly, I apply KVL in this branch. So in this branch, EB plus LS is in fact not plus, minus. EB minus LS. What is current in this branch? It is I3. di3 by dt. It is also equal to VP. This is equation 2. So this voltage minus this drop is equal to positive bus voltage. So EA minus LS di1 by dt is equal to VP. And similarly in this branch, this voltage EB minus this drop is also equal to positive bus voltage VP. That is EB minus LS di3 by dt is equal to VP. Let us add these equations. Adding equations 1 and 2. It will give me EA plus EB is equal to EA plus EB minus 2LS di1 by minus LS di1 by dt minus LS di3 by dt is equal to VP plus VP on the right hand side. So therefore I get something like this. What I get is EA plus EB minus, if I take LS common, LS, what I get inside is di1 by dt plus di3 3 by dt is equal to 2 Vp. Now what is I1 plus I3? You can see I1 plus I3 is equal to ID. So I1 plus I3 is equal to ID. So therefore I can write this equation as EA plus EB minus LS d by dt of, I can write I1 plus I3 is equal to 2 Vp, or I can write EA plus EB minus LS dId by dt is equal to 2 Vp, because I1 plus I3 is equal to ID. Now what is this load current? Load current is ID and load current is constant. It is a DC current. It's absolutely constant. And what is the differential of constant? What is differentiation of constant? It is 0. So this term is equal to 0. So therefore from this we will get EA plus EB is equal to 2 Vp, because this dId by dt is equal to 0. So this goes, this term goes. So therefore I get 2 Vp is equal to EA plus EB. What is, it's a balanced three-phase system. Assumption is that our system is a balanced three-phase system. So we can write as system is balanced. So EA plus EB plus EC is equal to 0. Sum of three phase voltages is equal to 0. So this will give me EA plus EB equal to minus EC. So therefore from this equation I will get 2 Vp is equal to minus EC, because EA plus EB is equal to minus EC. So this will give me positive bus voltage as Vp is equal to minus EC by 2. So this gives me positive bus voltage. Therefore my positive bus voltage is not equal to EA, it is not equal to EB also. It is equal to minus EC by 2 from this mathematical computation. So positive bus voltage Vp is equal to minus EC by 2. What about negative bus voltage? What is negative bus voltage? Vn. You can see negative bus is directly connected to phase voltage AC. So it is simply equal to EC. So therefore what is load voltage? I will write here. What is load voltage? Vd. That is equal to positive bus voltage minus negative bus voltage. So what is your positive bus voltage? We have just now computed it. It is minus EC by 2 minus negative bus voltage, that is EC. So therefore this gives me load voltage is equal to minus 3 by 2 EC, which means minus 1.5 EC. So therefore my load voltage during three value conduction drops from line voltage to phase voltage. And how much phase voltage? Minus 1.5 times phase voltage. You have seen in two value conduction in the last lecture, whenever a pair of valves is conducting, only because when U is equal to 0, only a pair of valves is conducting, 6, 1, 1, 2, 2, 3. And for conduction of each pair of valves, the load voltage is equal to line voltage, either EAB or EBC or ECA, etc., etc. So for each 60-degree interval, you get load voltage as segment of line voltages. But here you have seen when two valves were conducting previously, 1 and 2, our load voltage was equal to line voltage as expected, EAC. But when commutation between 1 and 3 took place for U electrical degrees, U degrees, that means during three value conduction, my load voltage is not equal to line voltage. It is equal to 1.5 times some phase voltage. So that means my load voltage is less, because even if it is multiplied by 1.5, it is still less than line voltage, because line voltage is √3 times phase voltage. And during three value conduction, I get load voltage as minus 1.5 times phase voltage. So that means there is a drop in the voltage, load voltage. So load loses some voltage. So therefore, whenever there is two value conduction, load voltage is equal to line voltage segment. And whenever two value conduction is followed by three value conduction, load voltage drops from line voltage to 1.5 times phase voltage. So there is dip or there is drop in the load voltage. So therefore there is a loss of voltage with commutation overlap. Okay, so therefore the general trick is that you can see that whenever two valves are conducting, upper two valves, your load voltage is minus 1.5 times. Say for example, just now we have seen when 1, 2 and 3 pair is conducting, when 1 and 3 is conducting and 2 is conducting. So for 1, 2, 3, your load voltage just now we have seen it is minus 1.5 times EC. So you should remember it like this. So 1 and 3 is conducting, 1 is connected to EA, 3 is connected to EB. So EA plus EB, you can say it is equal to minus EC. So 2 is also connected to EC. So minus EC by 2 minus EC gives minus 1.5 EC. Similarly, suppose 3 and 5 is conducting. Okay, say 3, 4, 5. Say for example 3, 4, 5. So in the upper group, 3 valves are connected. 3 is connected to phase voltage EB. 5 gets connected to phase voltage EC. So what will be your load voltage? You should remember that load voltage is equal to minus 1.5 times EA, because this is EB plus EC. EB plus EC is equal to minus EA. So your total load voltage, you can perform the same analysis. You can draw the equivalent circuit and you will get same. You will get load voltage equal to minus 1.5 EA. But without drawing the circuit diagram for each conduction of 3 valves, we can remember it this way. Similarly, say if 5 and 1 are conducting, 1 and 5 are conducting together, what is your load voltage? Which valve is not conducting? 3 is not conducting and 3 is connected to EB. So your load voltage at that time, you can say, blindly say it is minus 1.5 times EB. So I repeat, when 1 and 3 is conducting, okay, your load voltage should always be equal to minus 1.5 times the voltage of third phase, minus 1.5 EC. When 3 and 5 are conducting, your load voltage is equal to minus 1.5 times the voltage of third phase, minus 1.5 EA. Similarly, when 1 and 5 are conducting, your load voltage is minus 1.5 times EB. So you can remember it like this. Similarly, if in the bottom group of valves, if 4 and 6 is conducting, say 4, 6 is conducting, say in the upper group 3 is also conducting, 3, 4, 6, or 4, say 4, 5, 6, 4, 5, 6. That means 4 and 6 are conducting. What is load voltage? You should remember that load voltage is equal to 4 is conducting, 6 is conducting, which is not conducting? 2. And 2 is connected to EC. You should remember it is equal to 1.5 times the third phase voltage. You can draw the equivalent circuit and you will get the same. But this is the trick. This is how you remember without drawing the circuit diagram. And let us suppose 6 and 2 are conducting. When 6 and 2 are conducting, which is not conducting? 4. 4 means, so your load voltage will be equal to 4 is connected to EA, which is 1.5 times EA. And similarly, when 2 and 4 are conducting, 2 and 4, which is not conducting? 6 is 1 EB. So load voltage is equal to 1.5 times EB. So remember the trick. Whenever upper 2 valves are conducting in 3 valve conduction, upper 2 valves are conducting, your load voltage is 1.5 times the phase voltage. Similarly, in the bottom group of valves, whenever 2 valves are conducting, load voltage is plus 1.5 times the third phase voltage. So remember it that way. Draw the table and you will get that conduction table. Let us now draw the firing table. The first column, as you remember, is conducting valves. Conducting valves. Second column is from. Third column is to. Fourth column is load voltage VD, and fifth column is valve voltage. You can draw voltage across any valve. Let me take valve 3, because in 2 valve conduction also in the last lecture we have drawn the waveform for voltage across valve 3, V3. So we will continue with valve 3. Although you may be asked in the examination to draw voltage across any valve. So you should be able to draw the voltage across any valve. So here we have taken valve 3. Fine. So we will start with the firing of valve 3. So previously 1, 2 pair was conducting. Firing pulse is issued to valve 3. So 1, 2, 3. 1, 2, 3. So because firing pulse is issued to valve 3. 1, 2, 3 will be followed by 2, 3. Okay. Here commutation between 1 and 3 is taking place. So 3 valve conduction. 1 is outgoing valve, 3 is incoming valve. Once the commutation is over, 1 is completely off. So we get 2, 3, 2 valve conduction. Then firing pulse is issued to valve 4. So commutation between 2 and 4. Commutation between 2 and 4 will take place. So 2, 3, 4. It will again give 3 valve conduction. 2, 3, 4. Once the commutation is over, 2 is out, 4 is completely in, 3, 4. Then firing pulse is issued to value 5. So 3, 4, 5 during due, and then 4, 5. Then firing pulse is issued to value 6. So 4, 5, 6. Then 5, 6. And then firing pulse is issued to value 1. 5, 6, 1. Then 6, 1. And firing pulse is issued to value 2. 6, 1, 2. 1, 2. And then firing pulse is again issued to value 3. 1, 2, 3. So we reach back to this. So here firing pulse is issued to value 3 after 60 degrees. Firing pulse is issued to value 4. Then after another 60 degrees, value 5 is fired. Then after 60 degrees, 6. Then 1, then 2, and then 3 again. After every 60 degrees, a particular value is fired. So when value 3 is fired, because of commutation overlap, you get 3 value conduction, 1, 2, 3. And when commutation between 1 and 3 is over, you get 2 value conduction, 2, 3. Then when 4 is fired, there is commutation between 2 and 4. So it gives 3 value conduction, 2, 3, 4. And once commutation after U is over, you get 2 value conduction. So we can start with the firing of value 3. It gives 3 value conduction, 1, 2, 3, followed by 2 value conduction, 2, 3, 4. So 1, 2, 3, 2, 3, 2, 3, 4, 3, 4, 3, 4, 5, 4, 5, 4, 5, 6, 5, 6, 5, 6, 1, 6, 1, 6, 1, 2, 1, 2, and back to 1, 2, 3. This is how we get it. Now we will take both rectification mode of operation as well as inversion mode of operation. Let us assume for rectification mode of operation, alpha is 30 degrees, and for inversion mode of operation, it is 150 degrees. Alpha less than 90 degrees, so in this case 30 degrees means converter is operating as a rectifier, and if alpha is greater than 90 degrees, say in this case 150 degrees, your converter is operating as an inverter. So this is for rectification mode, we have assumed alpha 30 degrees. For inversion mode, we have assumed alpha 150 degrees. Now you already know when value 3 is fired, either at alpha equal to 30 degrees or alpha equal to 150 degrees, it gives 3 value conduction. And we have I have already explained during the 3 value, this 3 value conduction is there for U electrical degrees. And let us assume, let alpha be 30 degrees oblique 150 degrees for rectification oblique inversion, and let U be 15 degrees. Let us, since we are considering mode 1, U less than 60 degrees, let us assume U is 15 degrees. The converter transformer reactance is low, system inductance is low, and it gives commutation overlap of 15 degrees only. Okay, so therefore 3 value conduction will be there for, you already know that this 3 value conduction will be for U degrees, and 2 value conduction will be for 60 minus U degrees. So that means 60 minus U is 15 in this case, so 45 degrees. So whenever 3 value conduction is there, it will be for U degrees. U means 15 degrees. And whenever 2 value conduction is there, it will be for 60 minus U, that's 60 minus 15, 45 degrees. So we start with 3 value conduction, 1, 2, 3. So it is from 30 degrees to 30 plus 15. So since 3 value conduction is for 15 degrees, so 45 degrees for rectification mode of operation. And for inversion mode of operation, 150 to 150 plus 15, that is 165 degrees. Okay, this will be followed by 2 value conduction. So 2 value conduction is from 45 degrees oblique 165 degrees, that is this 2. And you can see 2 value conduction is for 45 degrees. So what is 45 plus 45 for rectification mode? It's 90 degrees. And for inversion mode, it is 165 plus 45. So it is 210 degrees. So you can continue like that. Then you can start from 90 degrees oblique 210 degrees. Again, there is 3 value conduction for 15 degrees. So that means 105 degrees. 90 plus 15 is 105 degrees oblique 210 plus 15 is 225 degrees. Then 2 value conduction. 2 value conduction from 105 degrees oblique 225 degrees to 105 plus 45 is 150 degrees oblique oblique 225 plus 45, 270 degrees. Okay, then 150 degrees oblique 270 degrees to again 15 degrees, 165 degrees oblique 285 degrees. Then 165 degrees oblique 285 degrees, 45 more, 210 degrees. 285 plus 45 is 330 degrees. Then again 3 value conduction for u degrees, for 15 degrees, 210 oblique 330 degrees is for 225 degrees oblique 345 degrees. Then again 2 value conduction from 225 oblique 345 degrees to 225 plus 45, that is 270 degrees. 345 plus 345 plus 45 means 390. 390 means 30 degrees. Then again 3 value conduction, 270 degrees oblique 30 degrees to 285 degrees oblique 45 degrees. Then 2 value conduction is from 285 oblique 45 degrees to 330 degrees oblique 45 plus 45 is 90 degrees. Then 3 value conduction from 330 oblique 90 degrees to 345 degrees oblique 105 degrees. Then 2 value conduction from 345 oblique 105 degrees to 345 plus 345 plus 45 is 390, that is 30 degrees oblique 105 plus 45 is 150 degrees. So you have reached back to where from you had started. And 1, 2, 3 is again from 30 oblique 150 degrees to 45 oblique 165 degrees. So when 1, 2, 3, see 1, 2, 3 pair 30, 150 to 45, 165. So again 30, 45, 30, 150, 45, 165 degrees. So this is the range of, conduction. 3 value conduction starting from here, then 2 value conduction, again followed by 3 value conduction, again 2 value conduction, and so on. Now let us see what is the load voltage. When 1, 2, 3 pair is conducting, remember 1, 2, 3, this is 3 values are conducting, 2 from upper group, 1 and 3, and 2 from lower group. Remember the trick, 1 and 3 are conducting, 1 and 3, which is not conducting, 5, and 5 is connected to EC, so your load voltage will be minus 1.5 phase voltage of non-conducting phase, minus 1.5 EC. We have mathematically through equivalent circuit already obtained this expression, so you can remember it like this. Now 3 value conduction is followed by 2 value conduction, 2 and 3. 3 makes positive bus voltage equal to EB, and 2 makes negative bus voltage equal to EC. So EB minus EC means EBC. Then again 3 value conduction, 2, 3, 4. 3 belongs to upper group. So only 1 from upper group and 2 from lower group. 2 and 4 are conducting. 2 and 4. So 2 is conducting, 4 is conducting. Which value is not conducting? 6. And 6 is connected to phase voltage EB. So by the trick, the load voltage is 1.5 EB. You can again draw the equivalent circuit same way that I have already done few moments back, and you will get same voltage. But this is the trick how you can remember it. So in the when upper pair of values is conducting, it is minus. When lower pair is conducting, it is plus. Remember. So 3 value conduction is followed by 2 value conduction, 3 and 4. 3 means EB and 4 means EA. So EBA, load voltage. Then again 3 value conduction, 3, 4, 5. 3 and 5. 3 is conducting, 5 is conducting, 1 is not conducting, and 1 is connected to EA. So it is minus 1.5 EA. It is followed by 4, 5. 5 makes load voltage EC and 4 EA. So it is ECA. Then 4, 5, 6. 4 and 6 in the bottom group are conducting. Which is not connected? 2. 2 is connected to EC. So it is plus 1.5 EC. Fine. Then 5, 6. 5, 6 means ECB. Then 5, 6, 1. 5 and 1 in upper group are conducting. 3 is not conducting. It is connected to EB. So minus 1.5 EB. Then 6, 1. 6, 1 means EA minus EB. So EAB. Then 6, 1, 2. 6 and 2 are conducting. 4 is not conducting. 4 is connected to EA, so minus 1.5 EA. Then 1, 2, 1 and 2, EA, EC, so EAC. And then it repeats, again minus 1.5 EC. So it is minus 1.5 EC, EBC, 1.5 EB, EBA. One more trick you can remember. So 1, 2, 3, 4, 5, 6. First 6 conductions is like this. Minus 1.5 EC, EBC, 1.5 EB, EBA, minus 1.5 EA, ECA. And then rest will be phase reversals of this. For example, when you start from here, what was this? It was minus 1.5 EC. What is it? Phase 180 degree phase reversed voltage. What is the phase reversed voltage of minus 1.5? It is plus 1.5 EC. And then this is EBC, its phase reversed voltage is ECB, right? Then this is 1.5 EB, so it will be minus 1.5 EB. And if this is EBA, this will be EAB, just opposite of this. This is minus 1.5 EA, so this has to be plus 1.5 EA. It has to be plus 1.5 EA, okay? And if this is ECA, this has to be EAC, okay? So this is how we complete the table. Now, what is the voltage across value 3? We know when a particular value is on during the conduction state, it drops no voltage ideally. So load voltage is 0. During first interval 1, 2, 3, 3 is conducting. So value 3 voltage is 0. During next interval 45 degrees, 3 is again conducting. So V3 is again equal to 0. Here 3 is again conducting, V3 is 0. Then 3 is again conducting, V3 is 0. 3 is again conducting, V3 is 0. And then 3 stops conducting, 3 is off. What has come in place of 3? 5. So 5 has come. So what is anode voltage of valve 3? It is always equal to EB, because anode is always connected to EB. And cathode voltage will be determined whether 5 is conducting or 1 is conducting. And during this period, 5 is conducting. So when 5 is conducting, 5 connects this EC to cathode of this. So it is EC. So therefore its voltage across valve is anode voltage minus cathode voltage. EB minus EC, that is EBC. It is EBC. And when 4, 5, 6, 3 valves are conducting. 4 is conducting, 5 is also conducting, and 6 is also conducting. What is voltage across valve 3? Voltage across valve 3, you can draw the equivalent circuit and find the voltage across valve 3. And from that you will get just opposite of this. This is 1.5 EC, it will be minus 1.5 EC. You can remember it like this also. Then what is voltage across valve 3 during this period? 5 is again conducting. See, here also 5 was conducting and valve voltage was EBC. So 5 is conducting, so it will be still EBC. Then 5, 6, 1, 3 valves are conducting. What is this load voltage? Minus 1.5 EB, and valve voltage will be just opposite of this, plus 1.5 EB. And then 6, 1, 1 is now conducting. So when 1 is conducting, see, it is anode voltage is EB, and when 1 is conducting, its cathode voltage is EA. And what is total voltage? V3. It is anode voltage minus cathode voltage, EB minus EA, that is EBA. Then, if this is the load voltage, valve voltage will be just opposite of this, minus 1.5 EA. And 1 is again conducting, so it will be again EBA. So then again it will be 0 because 3 again starts conducting. So this is how we find the valve voltage. So this completes our table. So with the completion of this table, we are now ready to draw the waveforms. Let us go to the table and draw the waveforms. Let us start drawing waveforms. So this is my waveform sheet. So this is my line voltage and this is the phase voltage. So let me first of all draw the omega t axis. So this is my waveform sheet. Let us draw the waveform. So this is my omega t. This is my omega t axis. First of all, I will show this omega t axis. This is my omega t axis. I will write here omega t. So I start with the finding of value 3. I will show here first for rectification mode of operation. I will write here A. Rectification mode. So we'll assume alpha equal to 30 degrees. Alpha equal to 30 degrees and U equal to 15 degrees. So we are considering mode 1, that is u less than 60 degrees. So we have first of all taken rectification mode of operation alpha 30 degrees and u 15 degrees. So therefore 3 value conduction will be there for u degrees, and u in this case is 15 degrees, and 2 value conduction will be there for 60 minus u degrees, that is 60 minus 15 degrees, that is 45 degrees. This we have already established. Let me draw the converter power circuit diagram again on the side of this waveform sheet. This is my waveform sheet and this is my converter. This is LD and this is load, LOAD, load. This is load voltage VD plus minus, and this is load current ID. And this is EA with source inductance LS and line current IA. And then this is EB. And then this is EC. Okay, fine. Now we start with the firing of 3. So we will have 1, 2, 3. Okay, followed by 2, 3. Same table I am reproducing it here. Then 2, 3, 4. 3, 4. 3, 4, 5. 4, 5. 4, 5, 6. 5, 6. 5, 6, 1. 6, 1. 6, 1, 2, 1, 2, and then again 1, 2, 3. Let me write load voltage VD in first column and second column value voltage V3. When 1, 2, 3, I mean 3 valves are conducting, what is your load voltage? You can see this is my 1, this is 3, 5. Let me label these valves 2, 4, 6. 1 and 3 are conducting, 1 and 3. Which value is not conducting? 5, and 5 is connected to phase voltage EC. Then I told you the trick is that the phase which is not conducting, you take minus 1.5 times its phase voltage, and this value 5 is not conducting and it is connected to voltage EC. So here therefore load voltage will be minus 1.5 EC. I am writing it here. I have already written it in that table, firing table. I am reproducing it here. Then 2, 3 pair is conducting. 3 is this and 2 is this. So my load voltage is EB minus EC. So my load voltage is EBC. Okay, fine. Then 2, 3, 4. 2, 3, 4 valves are conducting. That means 2 and 4 in the bottom are conducting. This is 2, this is 4. Which value is not conducting? 6. And you can see 6 is connected to voltage source EB. So therefore load voltage by that trick is plus 1.5 times EB. Fine. Then 3, 4 pair is conducting. This is 3, this is 4. 3 means EB, 4 means EA. So EB minus EA, that is EBA, is my load voltage. Then 3, 4, 5 pair is conducting. 3 and 5 in the upper group are conducting. 3 and 5. Which valve is not conducting? 1. 1 is connected to phase voltage EA. So it is minus 1.5 times EA. Then 4, 5 pair is conducting. 4, 5 means EC, positive bus voltage EC, and 4 means negative bus voltage EA. So it is ECA. Okay. So all other voltages I have already told you. Another trick, you just take 180 degree phase reversed voltage, just reverse of these. 4, 5, 6, I mean if 1, 2, 3 was, when 1, 2, 3 pair was, when 1, 2, 3 valve were conducting, load voltage was minus 1.5 EC. Just take opposite of it. So that is plus 1.5 EC. Next is 1, 5, 6 is conducting. What was the voltage here when 2, 3 pair was conducting? EBC. What is opposite of this? ECB. ECB. Okay. Then what was the voltage here? Plus 1.5 EB. Take minus 1.5 EB. Just opposite. What is voltage here? EBA. Okay. Just take opposite of it. EBA opposite is EAB. Okay. Phase reversed voltage. Then what was the voltage here? Minus 1.5 EA. Just take opposite of it, plus 1.5 EA. And what was the voltage here? ECA. And now voltage here will be EAC. That's it. My table is complete. This is my table. Now I will start drawing the waveforms with these. Now I can start with the finding of value 3. My value 3 is, what is the commutation voltage of value 3? If you remember, in our last lecture, I have already told you that commutation voltage of value 3 is EBA. So जिस वैल्यू की फायरिंग से आप स्टार्ट करेंगे, उसकी जो पहली वेव है वो आप रेफरेंस वेव लेंगे, उस पर्टिकुलर वैल्यू की वैल्यू वोल्टेज से आप स्टार्ट करेंगे. लेट अस सपोज दिस इज EBA. EBA is commutation voltage of value 3. EBA will be followed by ECA. Then ECA will be followed by ECB. EC will be followed by EAB, then EAC, then EBC, then EBA again. That's it. If you remember, I told you last time the line-to-line voltages are in this sequence: EAB, then EAC. A letter will remain same, B will be replaced by C. Then A दो बार आया, it will be replaced by next letter. Next letter is B. So EBC, C retain रहेगा. EBC and EBA, C के बाद A आएगा. अब ये भी दो बार आया, B के बाद A आएगा. B के बाद C आएगा. ECA and ECB. ECA and ECB. उसके बाद C भी दो बार आया, C के बाद A आएगा. Then again EAB. So this is how these line voltages, and following the same, you see EBA here is followed by ECA. Here also I have written EBA followed by ECA. Then you can see here ECA is followed by ECB and ECB is followed by EAB. So ECB is followed by ECA is followed by ECB. ECB is followed by EAB. Then EAB is followed by EAC. EAB, you can see it is followed by EAB here is followed by EAC, EAC by EBC. So EAB is followed by EAC, EAC by EBC, and so on. This is how to label. So I have started with the commutation voltage of value 3 because we start with the firing of value 3, and this is omega t equal to 0 degree. The zero crossing of commutation voltage of value 3 is taken as reference. Uske baad, what is your alpha? You can see alpha is 30 degrees. So where is 30 degrees? Here is the 30 degrees. यहाँ से यहाँ तक 30 degree है. Each crossing is, each crossover is 30 degrees. This is 30 degrees. This is 30 degrees. This is 30. ये हर एक crossover 30 degrees. So this is 30 degrees. So यहाँ ये आपका, you show alpha equal to 30 degrees. And which value is fired here? You can show value 3 is fired. Once you know the first value, firing of first value, then it is very easy to show the firing of other values, because each value is fired in sequence. I mean 3 is followed by 4, 4 is followed by 5, 5 is followed by 6, then 1, 2, and then 3 again. And each value is fired after 60 degrees interval each. That means if 3 was fired here, somewhere here, iske 60 degrees baad, 60 degree means yeah, 4 will be fired. इसके नेक्स्ट 60 डिग्रीज बाद ये यहाँ से यहाँ तक, क्योंकि यहाँ से यहाँ तक 30 है, यहाँ से यहाँ तक 30 plus 30 60, तो यहाँ से यहाँ तक it is 60 degrees. So 5 will be fired here. After next 60 degrees, that's here, 6 will be fired. After next 60 degrees, 1 will be fired. After next 60 degrees, 2 will be fired. Then again 3. We have started with 3, we have ended with 3. We reach back to 3. So this, once you know the firing instance, this is how you determine the firing instance of various valves. It's very easy. You start with the firing of value 3, whose commutation voltage is this EBA. You can see it's EBA is its commutation voltage, and this omega t equal to 0 is its zero crossing reference, and alpha equal to 30 degrees. यहाँ से यहाँ तक this is alpha equal to 30 degrees. So here you show firing of value 3, and it will be followed by 4 after every 60 degrees, then 5, 6, 1, 2, and 3. Now these are my line voltages. You can see these are my line voltages. See, what is this line voltage, by the way? It is EBC. EBC. And what is this line voltage? EAC. This is EAC. But as per this table, firing table, my line voltage, my load voltage is not equal to, when three valves are conducting, my load voltage is not line voltage. It is either minus 1.5 times some phase voltage or plus 1.5 times some phase voltage. So, but the problem is that this waveform shows 6 line-to-line voltages: EAB, EBC, ECA, ECB, similarly EAB, EBC, as 6 line-to-line voltages. Why do I show the phase voltages? And of course 1.5 times phase voltages. So this bottom curve will help you. इसके नीचे जो curve दिया है, you can see here phase voltages is written. Let me draw omega t axis first. This is omega t axis. Now these are my phase voltages. For example, this may be EA, this may be EB, and so on. Now, what is my commutation voltage here? This is commutation voltage EBA, and this EBA, I start from here. It is equal to 0 here. You just take this projection down. EBA equal to 0 means आप यहाँ पे हैं. When will EBA, in fact, it is this point. In fact, if you assume that this corresponds to this point. See, this point and this point is the same. उसका मतलब ये हुआ कि at this point, what does EBA equal to 0 mean? I have written here, EBA equal to 0 means EB minus EA is equal to 0. That means EB should be exactly equal to EA. When EB is equal to EA, what is EBC? That is EB minus, what is EBA? EBA is EB minus EA, and if EB is exactly equal to EA, so EBA, therefore EBA is equal to EB minus EA, that is equal to 0. That's possible only when the two phase voltages are exactly equal to 0, exactly same, and that happens somewhere here at this point. So now you see here EBA is 0. अगर आप इसको नीचे लेते हैं, it coincides with this instant. That means this voltage should be EB. ये आपकी EB होनी चाहिए और ये voltage EA होनी चाहिए. तभी तो you can see this EA and EB at this point, they are equal. When the two voltages are equal, so at this point EBA, which is equal to EB minus EA, is equal to 0. तो इससे आपको पता चलेगा कि आपकी पहली voltage, phase voltage क्या है? EB. So this is your first phase voltage, EB. After 120 degrees, आपकी next voltage आएगी, EB will be followed by EC, and EC will be followed by EA. So मैंने यहाँ EB पहले label किया है क्योंकि मुझे यहाँ से पता चला EB. I mean, you could say that, sir, how do you say that this voltage waveform is EB? I am saying because at this point EB is exactly equal to EA, that is this point. So this has to be EB and this has to be EA. So that at this point EB is exactly equal to EA and EBA is equal to EB minus EA is equal to 0, which corresponds to this point. So therefore this gives me idea about what should be this first waveform. So this first waveform should be phase voltage EB. 120 डिग्री के बाद, 120 डिग्री means 30 plus 30 60 plus 30 90 plus 120 डिग्री means ये. इसके बाद EC आपका शुरू होगा. इसके 120 डिग्री के बाद 30 plus 30 60 plus 90 ये EA शुरू होगा. तो दैट मीन्स अगर ये आपका EB है, एक आप ये छोड़ दीजिए, नेक्स्ट शुरू कर दीजिए, ये EC है. सो दिस EC लैग्स बिहाइंड EB पे 120 डिग्रीज. यह अगर आपका EC है, उसके बाद एक छोड़ के एक आ जाएगा आपका EA, एंड EA लैग्स बिहाइंड EC पे 120 डिग्रीज. नाउ वंस यू नो EB, व्हाट इज माइनस EB? माइनस EB इसकी मिरर इमेज है. दैट मीन्स अगर ये आपका EB है, दिस विल बी माइनस EB. आप ऊपर जाइए, सो दिस इज माइनस EB. Fine. Similarly, if this is your EC, see, this is your plus EC. What is this minus EC? It's phase reversed voltage. If mirror image, this is minus EC. ये मेरी minus EC है on this side, and if I go on this side, this is minus EC. Similarly, ये मेरी EA है. This is my EA. You can see this is my EA. इसकी mirror image ये है. That will be minus EA. Minus EA on this side, and minus EA on this side. So what is this? ये देखिए, ये आपकी minus EB है, so this will be plus EB. So this is how we label these voltages. Fine. In the lower waveform, we have already labeled various phase voltages, like this is EB, this is minus EA, this is EC, minus EB, EA, minus EC, EB, and minus EA again. Now the question is, when 1, 2, 3 pair, when 1, 2, 3 valves are conducting, my load voltage is minus 1.5 times EC. Okay, you can see minus 1. But here I have only line voltages. You can see I have line voltage EBC, then this line voltage EBC is followed by EBA, ECA. How do I show these phase voltages? So what we do, ये हमारी phase voltages है नीचे, like ये मेरी EC है, ये EB है, ये minus EA है, right? This is of course minus EC. This is minus EC. ये मेरी minus EC है. अगर आप ये EC, see, look very carefully. If you multiply this minus EC by 1.5, see, this waveform. This waveform is my minus EC. You can see it is minus EC. मैंने यहाँ पे लिखा है और यही waveform है. If I multiply it by minus EC को multiply करूँगा 1.5, this waveform को, और इसको ऊपर ले जाऊँगा. And if I try to draw it on the same omega t axis, ये omega t axis पे, do you know where it will fall? You can try it yourself. It will fall here. ये देखिए इसका पीक ये है. जब आप इसको ऊपर ले जाएंगे, ये coincide करता है इस जीरो, इस crossover point के साथ. So it will follow like this. You can try it in your MATLAB. I hope most of you know how to use MATLAB software or any other software, PSIM or any other software. You can draw these three-phase line-to-line voltages, 6 line-to-line voltages, and on the same axis there, you can draw various phase voltages like plus 1.5 EA, minus 1.5 EA, plus 1.5 EB, minus 1.5 EB, plus 1.5 EC, minus 1.5 EC. You will see those waveforms will pass through these crossover points. This crossover point, this crossover point, this crossover, ऊपर और नीचे भी ये crossover points से they will pass this. So what, in other words, what you do, yeah, आपकी, this is minus EC. If you multiply it by 1.5, this becomes your minus 1.5 EC. अगर आप इसको ऊपर ले जाएंगे इसी तरह, so it will pass through this crossover point, अच्छा, now you can see this minus EC, जो minus 1.5 EC है, 0 हो जाती है somewhere here. तो अगर that means अगर आप इसको नीचे ले जाएंगे तो ये रिप्रोड्यूस होगी, ये 0 हो जाएगी. उसके बाद इसका नेगेटिव हाफ साइकिल शुरू हो जाएगा. बट यू डोंट नीड टू ड्रॉ द एंटायर पॉजिटिव एंड नेगेटिव हाफ साइकिल. आई नीड ओनली दिस पोर्शन, स्टार्टिंग पोर्शन, दिस. सो आई कैन नोट डाउन नाउ, आई कैन राइट हियर दिस इज minus 1.5 EC. ये मेरी ये EC है, इसको मैंने स्केल किया है. आई हैव मल्टीप्लाइड इट बाय minus 1.5. इसको यहाँ से उठा के सेम ओमेगा टी एक्सिस पे जब मैं प्लॉट कर रहा हूँ तो इट पासिस थ्रू दिस. यू कैन सी. Okay, it is true. What is my next voltage? You can see my next voltage is EB. If you multiply it by 1.5, so this becomes 1.5 times EB. और इसको जब आप ऊपर ले जाएंगे, you see, जब आप इसका पीक देखिए, इसके साथ coincide करता है. इसका पीक इस crossover के साथ coincide करता है. That means it passes. जब आप इसको ऊपर ले जाएंगे और same omega t axis पे plot करेंगे, so it will follow this path. So this is plus 1.5 EB. Fine. What is my next voltage? It is minus EA. इसको जब मैं ऊपर ले जाऊंगा, it will become minus 1.5 EA. So next crossover point is this. It will become minus 1.5 EA. My next voltage is EC. When I take it up, it passes through this crossover point. I am drawing only a portion of this. I am not drawing the entire cycle, positive and negative half cycle. So this is 1.5 EC. Okay. Next is minus EB. This is EC. Next is minus EB. When I multiply it by 1.5 and plot it on the same axis as this, it becomes minus 1.5 EB and it passes through this crossover point. This is minus 1.5 EB. उसके बाद EA. This is 1.5 times EA. उसके बाद minus EC फिर से minus 1.5 EC. Fine. So these are you can draw the complete positive half cycle and complete negative half cycle, but you don't need to do that. I need it only for a small period here. You will come to know about it in a minute's time. Please bear with me. So now if this is my what is this? This is my this portion of waveform is 1.5 times some phase voltage, say minus 1.5 times EC. अगर मैं इसकी मिरर इमेज ड्रॉ करूंगा नीचे से, इसकी फेज रिवर्स वोल्टेज ये, it will be plus 1.5 EC. See, this is minus 1.5 EC. अगर आप पूरा साइकिल ड्रॉ करेंगे, उसका फेज अपोजिट ड्रॉ करेंगे, that will become plus 1.5 EC. So that means if this is your minus 1.5 EC, this will be your plus 1.5 EC, only a portion of it. Similarly, what is your next voltage segment here? It is plus 1.5 EB. इसका फेज रिवर्स्ड वर्शन ये होगा, it will be minus 1.5 EB, right? What is the next voltage, phase voltage segment? Minus 1.5 EA. इसकी mirror image यहाँ से pass होगी, it will be plus 1.5 EA. I will write here 1.5 EA. Next is 1.5 EC. If this is plus 1.5 EC, this will be minus 1.5 EC. Here I will write minus 1.5 EC. Similarly, this is minus 1.5 EB. This is minus 1.5 EB. This will be plus 1.5 EB. This plus 1.5 EB. Similarly, this is plus 1.5 EA. This will be just इनकी mirror images नीचे draw कर लीजिए. This is minus 1.5 EA. Similarly, this is again minus 1.5 EC. इसकी mirror image होगी ये plus 1.5 EC. So I am ready with the guns now. I am ready. So now I can draw the waveforms. Let me use red pen for drawing the load voltage waveform. So before I go to the load voltage waveform, value voltage I have forgotten to write here. 3 is conducting during this period. So value voltage is 0, 0, 0, 0, 0 for first 5 intervals. Because 3 starts conducting from here and it continues up to here. Uske baad 4, 5 pair is conducting. 5 is conducting, go to the converter. Its anode voltage is EB, cathode voltage through 5 is EC, so EBC. Therefore it will be EBC. Yeah. Then 4, 5, 6 is conducting. If load voltage is plus 1.5 EC, I have already told you that value voltage will be minus 1.5 EC. Then 5 is again conducting here. 5 ऊपर भी conduct कर रहा था, so load value voltage was EBC, it will remain EBC. Then during this period, 561 values are conducting. Load voltage is minus 1.5 EB and value voltage will be plus 1.5 EB. Okay. Uske baad 61. Now 1 is conducting. See, this is 1. Your anode voltage is EB and 1 is conducting means cathode voltage is EA. So EBA. EBA. Then 6, 1, 2 are conducting 1.5. This is 1.5 EA, so value voltage will be minus 1.5 EA. Then 1 is again conducting, so it will be EBA. Fine. So now we are ready for drawing the waveforms. Now our first instant is here from 30 degrees to 45 degrees. 1, 2, 3 valves are conducting and your load voltage is minus 1.5 EC for 15 degrees. यहाँ पे आप 3 fire कर रहे हैं. You are firing 3 here. And load voltage for, see, यहाँ से यहाँ तक, see, each crossover point, this is 30 degrees. ये यहाँ से यहाँ तक 30 degrees है, 15 degree बीच में होगा somewhere here. And what is load voltage during 15 degrees? It is minus 1.5 EC. And why is minus 1.5 EC? आपने पहले ही draw किया है. You see, this is minus 1.5 EC. ये है आपकी minus 1.5 EC. So ये यहाँ से शुरू हो जाएगा. And it will remain there for 15 degrees. So यहाँ से यहाँ तक आपका 30 degree है, 15 degree बीच में somewhere है. So this is your load voltage, minus 1.5 EC for 15 degrees. उसके बाद you can see 2, 3 valves are conducting and load voltage is EBC. Now where is EBC? EBC just इसके ऊपर है. Go up. Just ऊपर है. ये EBC will continue till next instant of firing. से पहले मैं ये ऊपर ले जाऊँगा सारे instants of firing. This is next instant of firing. This is next instant of firing. this is next instant of firing, this is next instant of firing. Okay. Now my load voltage when 2 3 pair is conducting for remaining 45 degrees, load voltage is EBC. Now you can see this is your EBC, so it will follow this till next firing. Next firing 4 यहाँ हो जाती है, तो यहाँ से यहाँ तक लोड वोल्टेज EBC हो जाएगी. अब यहाँ पे 4 फायर हो रहा है, so 2 3 4 will conduct now. Now 2 3 4, and what is load voltage for 15 degrees? It is 1.5 EB. And now you see, why is 1.5 EB? This is your 1.5 EB. Immediately ये आपकी 1.5 EB है. So you can go up, come down. उसके बाद आपको टेबल वेबल देखने की जरूरत नहीं है. आप ब्लाइंडली फिर देखिए, ये आपका पहला सेगमेंट मिल गया ना. If this is first segment 15 degree segment, ये 45 degree segment है. उसके बाद ये 15 degree segment है, and then symmetrically this is 45 degree segment. So shade it, and then ये आपका फिर से next 15 degree segment है, and this is 45 degree segment. So you continue blindly like this without looking at the table till next firing. Next firing आपकी यहाँ पे होती है. So next firing जब होती है तो ये 15 degree interval है. This is 45 degree interval. So continue like this. Okay, so 15 degree, 45 degrees, like this. Follow this pattern. Then you can see this is 15 degrees followed by 45 degrees. That's it. उसके बाद 3 फिर से fire होता है. So this is your load voltage. So therefore your load voltage for when 1 2 3 is conducting. So during this period 1 2 3 is conducting, then 2 3, then 2 3 4, then 3 4, then 3 4 5, then 4 5, and so on. When 1 2 3 are conducting, these 3 for 15 degrees, your load voltage is minus 1.5 EC. And when 2 2 3 are conducting, for 45 degrees, up to next instant of firing, your load voltage is EBC. Then your load voltage is when 4 is conducting, 2 3 4 values are conducting, your load voltage is 1.5 EB for 15 degrees. For 45 degrees it is EBA. Then your load voltage is minus 1.5 EA, then ECA. So continue like this blindly. So this gives your load voltage waveform. See, for 2 value conduction, if you remember, I will put this here. This is for 2 value conduction. In 2 value conduction also you started with the firing of value 3, and you were for entire 60 degree interval, आपके पूरे 60 degree interval में आपकी load voltage थी EBC. But what happens here? This is your entire 60 degree interval, यहाँ से यहाँ तक. Your load voltage is not EBC. For इस 60 degree interval में for 15 degrees your load voltage is minus 1.5 times EC. Okay, your load voltage is minus 1.5 times EC. ये for 15 degrees it is EBC, जबकि यहाँ पे पूरे 60 degree में EBC थी, line voltage. Here for 15 degrees it is 1.5 times phase voltage, and then for 45 degree it is line voltage. Then again for 15 degrees it is 1.5 times some phase voltage, and then it is line voltage. So that means there is a drop in the voltage. Otherwise for 2 value conduction, this should have been your load voltage. This. But in each 60 degree interval for 15 degrees there is drop in the voltage. Here also for 15 degrees there is drop in the voltage. Here again for 15 degrees there is drop in the voltage. So therefore this is the waveform for load voltage. So this is our load voltage. I will write here, this is VD, load voltage, for alpha equal to 30 degrees and U equal to 60 degrees. Let us draw voltage across the value, for which I will use another pen. Now you can see our value 3 starts firing from here. So 1 2 3 2 3 2 3 4 3 4 3 4 5 4 5. तो यहाँ तक 1 2 3 2 3 2 3 4 3 4 3 4 5, then 4 5. That means value 3 starts conducting. This is value 3 voltage. I will write V3. It starts from here and its conduction ends here. 1 2 3 2 3. So 3 is conducting here, 3 is conducting here also. 2 3 4 3 4 3 4 5. So value voltage V3 is 0 all over this interval. Now let us come to this 3 4 5 यहाँ तक. वैल्यू वोल्टेज 0 है. उसके बाद 4-5 पेयर इज कंडक्टिंग. व्हाट इज वैल्यू वोल्टेज? Value voltage is EBC for 45 degrees. Where is EBC? You have to search this EBC. ये आपकी, ये देखिए, ये आपकी EBC है. This is EBC. ये. So therefore ये EBC को follow करेगा till next value is fired. Next value आपका 6 यहाँ पे fire हो रहा है. So it will follow EBC. ये आपका EBC है. उसके बाद see, for 4-5 conduction, value voltage was EBC. Then for 4-5-6 conduction, value voltage is minus 1.5 EC. Where is minus 1.5 EC? Just इसके नीचे ये देखिए, this is minus 1.5 EC. मैंने already लिखा हुआ है, ये आपकी minus 1.5 EC है. तो for 15 degrees ये इसी को follow करेगा, यहाँ से यहाँ तक 15 degrees, यहाँ से यहाँ तक 30 degrees है, तो 15 degrees यहाँ से यहाँ तक. So it will follow for 15 degrees, it will follow this. Okay. Because यहाँ से यहाँ तक 30 degrees है, but this is only for 15 degrees. उसके बाद value voltage again EBC हो जाती है. So EBC यही curve है, same curve. So it will come down again and it will follow till next instant of firing this EBC. यह आपकी EBC है. राइट. उसके बाद आपकी वैल्यू वोल्टेज EBC के बाद क्या हो जाती है? प्लस 1.5 EB. एंड वेयर इज 1.5 EB? दिस इज योर 1.5 EB. ये देखिए, मैंने ऑलरेडी लिखा हुआ है 1.5 EB. ये दिस इज 1.5 EB. इसको आगे ले जाए. सो फॉर 15 डिग्रीज, यहाँ से यहाँ तक 30 डिग्रीज है, 15 डिग्री बीच में समवेयर है. सो इट इज़ 1.5 EB. 15 डिग्री, नॉट होल 30 डिग्री. 15 डिग्री, यहाँ से यहाँ तक 15 डिग्री है. सो इट फॉलोज दिस 1.5 EB. उसके बाद it becomes EBA. After 1.5 EB, it becomes EBA. Where is EBA? You have to search this EBA. This is your EBA. See, this is EBA. तो ये इसी EBA को फॉलो करेगी. सो ये ड्रॉप हो जाएगी. इट विल कम डाउन एंड इट विल फॉलो दिस EBA. ये आपकी EBA till value 2 is fired. So when value 2 is fired, what is the voltage? When value 2 is fired, that means 612 is conducting. Your value voltage is minus 1.5 EA. Why is minus 1.5 EA? ये है आपकी minus 1.5 EA. ये. So for 15 degrees, it will follow this. यहाँ से यहाँ तक 15 degrees है. उसके बाद it is again EBA. It is again EBA. So EBA यही है ऊपर वाली curve. This is EBA. So इसी को follow करेगा till next instant of firing. उसके बाद 3 फिर से फायर हो जाता है and value voltage again becomes equal to 0. So this is the value voltage. Initially for 5 intervals it is 0, then it follows this pattern. So this is load voltage VD for rectification mode of operation, alpha equal to 30 degrees and U equal to 15 degrees, and this is the voltage across value voltage V3. So this is for rectification mode of operation. Let us quickly draw for inversion mode of operation. Okay, now we are drawing the waveforms for inversion mode of operation. I have written here inversion mode, alpha equal to 150 degrees and U equal to 15 degrees. This is the converter circuit, and I have already drawn this table. 1, 2, 3, 2, 3, 2, 3, 4, 3, 4, and our load voltages are minus 1.5 EC, EBC, plus 1.5 EB, and so on. And this is the value voltage for different intervals. Now, these are my voltages. This is EBC, EBA. I have already labeled them, and these are my 1.5 times phase voltages. For example, let me first of all complete them this way. You need to draw only a portion of that these waveforms, not complete positive half and complete negative half. You need just portions. Similarly, here you can continue like this. You can continue like this. Okay, fine. What is my first voltage? It's minus 1.5 EC. Okay, this is minus 1.5 EC. My next voltage should be plus 1.5 EB. This is plus 1.5 EB. Okay, my next voltage should be minus 1.5 EA. You see, this is minus 1.5 EC followed by 1.5 EB and minus 1.5 EA. So this is minus 1.5 EA. What is next voltage? My next voltage is plus 1.5 EC. So that is plus 1.5 EC. My next voltage is, I am here now, minus 1.5 EB. So this is minus 1.5 EB. And my next voltage is plus 1.5 EA. So this is 1.5 EA. So these are my different voltages. And these voltages are, phase opposite, phase reversed voltages. That means if this is minus 1.5 EC, this will be plus 1.5 EC. I am writing here plus 1.5 EC. This is my 1.5 EB. This will be minus 1.5 EB. Minus 1.5 EB. This is minus 1.5 EA. So this is plus 1.5 EA. This is 1.5 EC. And this will be minus 1.5 EC. This is minus 1.5 EB, you can see. So this is plus 1.5 EB. This is 1.5 EA. So this will be mirror image minus 1.5 EA. And that's it. That's it. So I have drawn these. Now I have, this is EBA. EBA is this voltage waveform. This is the commutation voltage of value 3. So obviously, so therefore its zero crossing is this. So this is omega t equal to 0. So what is my this delay angle, delay or firing angle? My delay angle is 150 degrees. So start counting 150 degrees. So this is 30 plus 30 60, 60 plus 30 90, plus 30 120 plus 30 150. So this is 150 degrees. तो ये आपका डिले है. This is alpha equal to 150 degrees. And after a delay of 150 degrees, your control logic circuit will issue firing pulse to value 3. Value 3's firing will be followed, sequentially by value 4 after 60 degrees. So यहाँ से यहाँ तक 60 degrees है. So that means if value 3 was fired here, here value 4 will be fired. Then here value 5 will be fired. Then here value 6 will be fired. Then value 1 will be fired. Then 2 and then again 3. This is how firing of valves takes place. I have started with 3, after 60 degrees 4, then after 60 degrees 5, then 6, 1, 2 and 3 and so on. Let me take these firing instants up because I require them later on. Okay, fine. Now after a delay of 150 degrees, valve 3 is fired. So 1, 2, 3 pair, 1, 2, 3 valves will conduct. And they will conduct for 15 degrees, that is from 150 degrees to 165 degrees. And my load voltage during that period is minus 1.5 EC. What is minus 1.5 EC? You will not see, this is minus 1.5 EC. अगर आप इसको बिल्कुल नीचे ले जाओगे, it will coincide with this minus 1. See, it will come down. See, let me take it down. It will come down. और ये इस minus 1.5 EC के साथ मिल जाएगी. Already I have drawn minus 1.5 EC. I mean, if you draw complete positive half cycle of, this is your minus 1.5 EC. If you draw its positive half and then its negative half, its negative half is this. So I have already shown it. So this is minus 1.5 EC. And this is alpha equal to 150 degrees. So 15 डिग्री तक मेरी लोड वोल्टेज जो है माइनस 1.5 EC हो जाएगी, माइनस 1.5 EC. सो यहाँ से यहाँ तक 30 डिग्रीज है, लेकिन इट विल बी फॉर 15 डिग्रीज ओनली. तो यहाँ से यहाँ तक 15 डिग्रीज है. सो माई लोड वोल्टेज इज माइनस 1.5 EC फॉर 15 डिग्रीज. Thereafter, what is my load voltage? My load voltage becomes EBC for 45 degrees, means till next instant of firing. What is EBC? Now you search EBC. This is your, see, this is your EBC. See, it is coming down, 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 down. here it is. So that means यहाँ से voltage jump हो जाएगा and it will follow EBC for next 45 degrees. Next 45 degrees means till 4 is fired, till next instant of firing. So my load voltage is equal to EBC. Fine. Got it? Now after that, 2, 3, 4 valves will conduct and load voltage is 1.5 EB for 15 degrees. Why is 1.5 EB? It's very clearly shown here. This is 1.5 EB. See, this is 1.5 EB. I have already written here. सबसे पहले आप यही दिखाइए वेवफॉर्म ड्रा करने से. This is 1.5 EB. इसको थोड़ा extend कर लीजिए. So my load voltage now becomes for 15 degrees only. So यहाँ से यहाँ तक 30 degree है. इसका half ये है. So it is 1.5 EB. उसके बाद, what is my load voltage? My load voltage becomes EBA. This is EBA. Where is EBA? This is EBA. This is EBA. ये मेरा EBA. ये. So it will jump up. So यही pattern follow करेगा. जो पहला pattern था वही pattern follow करेगा till next instant of firing. This is my next instant of firing. उसके बाद आपको table देखने की जरूरत नहीं है. You just blindly go. ये देखिए पहले आप गए ना 15 degrees, 45 degrees, then 15 degrees, 45 degrees. Then again you take next this voltage minus 1.5 EA for 15 degrees. और उसके बाद उसके बाद आप जंप करते हैं ऊपर. यहाँ भी आप ऊपर जंप कर लीजिए. So this will be ECA. ये आपकी ECA होगी till next instant. So continue like this blindly. You don't need to see the table. Continue like this. आपको सिर्फ पहला instant first 2 segments आपको पता चलने चाहिए. बाकी segments just same pattern follow करेंगे. That's it. We got it. Got it. So this completes our load voltage waveform VD. This is load voltage waveform. Now for inversion mode of operation, we already know our load voltage should be negative. And it is for rectification mode, you have already seen your load voltage is positive. See, it is positive. Average load voltage is also positive. For inversion mode, for alpha equal to 150 degrees, load voltage has to be negative. So it is negative. Its average voltage is also negative. Now again, I would like to say that if this if 2 value conduction was there, your conduction would have been from this instant to this instant. I mean, it would have been EBC completely here to here, then EBA, then ECA. These dropped voltages, 1.5 times phase voltages would not have been there. Throughout the 60-degree interval, your load voltage would have been line voltage itself. But because of the commutation overlap, for commutation overlap period, that's U degrees, when 3 values are conducting, your load voltage drops from line voltage to this 1.5 times some phase voltage. Then for 45 degrees, it is line voltage. Then for again 15 degrees, when 3 value conduction is there, it is again 1.5 times some phase voltage. Then for remaining 45 degrees, it is line voltage. Then it again drops to 1.5 or minus 1.5 times some phase voltage, then line voltage. So that means there is, during these 15 degree or U degree intervals or commutation overlap periods, there is drop of voltage from line to 1.5 times phase voltage. So therefore, the converter loses the voltage. There is loss of voltage. Anyway, this was about phase voltage. Load voltage. Let us draw the valve voltage. Our valve starts conducting from here. से देखिए 3 यहाँ पे conduct होता है. 1 2 3 2 3 2 3 4 3 4 3 4 5. तो यहाँ तक valve 3 conduct करेगा. So let us draw valve 3 voltage V3. यहाँ से यहाँ तक. Your valve voltage will be 0 because valve 3 is conducting during this period. उसके बाद आप टेबल जाइए और valve voltage देखिए. यहाँ तक valve voltage आपकी 0 थी. When 4-5 pair is conducting, your valve voltage is EBC. Where is EBC? Just search EBC. ये आपकी EBC है. ये देखिए. This is EBC. तो ये jump करेगा. It will follow EBC till next instant of firing. Next instant of firing is this. तो ये EBC को follow करेगा till next value is fired. देखिए. To follow EBC. So you were here EBC. EBC के बाद आपकी valve voltage minus 1.5 times EC हो जाती है. अब minus 1.5 times EC कहाँ पे है? Why it is minus 1.5 times EC? This is minus 1.5 times EC here. Minus 1.5 times EC.
इसके ऊपर ही, जस्ट ऊपर। तो ये दिस इज 1.5 टाइम्स ई, तो ये इसी को फॉलो करेगा 15 डिग्रीज तक। तो ये दिस इज माइनस 1.5 टाइम्स ई सी, ये देखिए दिस इज माइनस 1.5 टाइम्स ई सी, आई हैव ऑलरेडी रिटन हियर। सो 15 डिग्रीज यही रहेगा। उस 15 डिग्री के बाद आपकी लोड वोल्टेज फिर वैल्यू वोल्टेज फिर से ईबीसी हो जाती है। ईबीसी यही है, दिस इज ईबीसी, बिकॉज अर्लियर फॉलोइंग ईबीसी, इट विल नॉट फॉलो ईबीसी अगेन टिल नेक्स्ट इंस्टेंट ऑफ फायरिंग फॉर 45 डिग्री, ये ईबीसी है आपकी। उसके बाद आपकी वैल्यू वोल्टेज, नाउ यू आर हियर, ईबीसी के बाद फॉर 15 डिग्रीज आपकी वैल्यू वोल्टेज 1.5 ईबी हो जाती है, एंड दिस इज 1.5 ईबी, 1.5 ईबी, दिस इज 1.5 ईबी। इसको एक्सटेंड कर लीजिए तो ये इसी को फॉलो करेगा, ये इट विल कम डाउन, एंड फॉर 15 डिग्रीज इट विल बी 1.5 टाइम्स ईबी। This is your 1.5 times EB. I have written here, and it will for 15 degrees it will follow this. उसके बाद it will be EBA. You can see EBA. What is EBA? इसके just नीचे ये EB है, तो ये drop हो जाएगा और till next firing it will follow EBA. ये आपकी EBA. Okay? उसके बाद आपकी value voltage minus 1.5 times EA हो जाती है. So that is this. I should have labeled this. This is minus 1.5 times EA. तो इसको एक्सटेंड कर लीजिए तो ये इसी को फॉलो करेगा फॉर 15 डिग्रीज, इट विल बी 1.5 टाइम्स EA. उसके बाद इट विल बी अगेन EBA. EBA आपका यही है, सेम, ये ऊपर वाली वेव फॉर्म EB. सो इट विल गो अप और ये EBA को फॉलो करेगा टिल 3 इज फायर, और यहाँ पे 3 फिर से फायर होता है और वैल्यू वोल्टेज फिर से 0 हो जाती है. सो दिस इज योर वैल्यू वोल्टेज. This red waveform shows value voltage 0, then EBC, and it follows then 1.5 times some voltage, and like this. One very important you should remember from here, that for rectification mode of operation, this is for rectification mode of operation, your value voltage for most of the time is negative, and for very small time it is positive. But for inversion mode of operation, your value voltage for most of the time is positive, and it is negative only for small period. So this is one of the features of phase controlled converters. When the converter is operating in rectification mode of operation, the value voltage for most of the time remains positive. And when the converter operates in the inversion mode of when converter operates in rectification mode of operation, value voltage for most of the time remains negative. And when the same converter operates in the inversion mode of operation, for most of the time value voltage remains positive. This has got some importance, some significance, which I will discuss maybe in some of the future classes. So therefore, I have completed my discussions on 2 and 3 value conduction. We have in today's lecture assumed that we have taken the practical case. We have assumed that the source has got inductance, and because of that inductance there is commutation overlap. Okay, and then different modes were identified: mode 1 U less than 60 degrees, mode 2 U equal to 60 degrees, mode 3 U greater than 60 degrees. For mode 1 U less than 60 degrees, you get 2 and 3 value conduction. For mode 2, which we will discuss in future classes inshallah, we will get 3 value conduction. And for mode 3, that is U greater than 60 degrees, you get 3 and 4 value conduction. Today we discussed mode 1, that is U less than 60 degrees, and we took 2 cases for rectification mode. This is the waveform for rectification mode. In the rectification mode of operation, we assumed alpha to be 30 degrees, and we assumed commutation overlap angle 15 degrees. So therefore 3 value conduction is for 15 degrees and 2 value conduction for 60 minus 50, 45 degrees. And we have drawn the waveforms. And for rectification mode, for alpha equal to 30 degrees, this is the type of waveform, load voltage waveform we got. And this is the type of voltage across value 3 we have got. And next we have drawn the waveform for inversion mode of operation, alpha 150 degrees and U same 15 degrees. So we again get 2 and 3 value conduction. So this is 3 value conduction followed by 2 value conduction, then 3, 2 and so on. And using this table, we have drawn the load voltage waveform. Since we are operating the converter in inversion mode of operation, this is the inverter, this is the load voltage waveform. 1.5 minus 1.5 times some phase voltage and then line voltage, then 1.5 times some phase voltage and line voltage. Okay, and voltage across value 3 is this red color. So with this I will end my today's lecture. I will share these waveform sheets with you on WhatsApp group and also on Google Classroom. And please try to draw these waveforms yourselves. And in case of any difficulty, you can revert to me, you can discuss with me. Thank you.